lecture and lesson 14. Going to be talking about collision domains. So what you'll hear is we've got collision domains and what we call broadcast domains. And we will talk a little bit about broadcast domains, but it will have its separate video. So we're going to be using Packet Tracer once again for the topology. On this one I'll be switching between GNS3 and Packet Tracer, so you guys, whichever you prefer to use, you can use. So without further ado, let's go ahead and get into it. So if we look over here, we got a monitor. We've got a few set up here, so we're going to go over the setup. So you can see I got two sections here, as I want you to be able to see and get an idea. So we got PCs around, and this connection in the center here is a hub. So this is what they call a hub device, and this is a switch. Now a hub is also known as a multi-port repeater. It's one of the names that it will have. So we need a hub to help demonstrate collision domains and how they work. Luckily, switches has made collision domains separate. Therefore, they do not have collisions like a hub would. Now a hub forwards traffic out of all ports. It has no MAC address table. So hence the name that switch came along when it had a MAC address table. It knew where to send something into which port once it's built its MAC address table. Well, a hub doesn't. So when you ping, it actually goes to all PCs the entire time. So, and only the PC that it's trying to contact will support. Where a switch, the first time it might go to all the PCs, but after that, it will directly connect between the two by the switch. So I want you all guys to understand that. So, alright, we're looking at a hub here. So, with that being said, let's talk a little bit about this. So, the question you'll have, and I will promise you, you're going to see something like this in the ICND 1 without a doubt. So, you need to know your collision domains and your broadcast domains. So, with that being said, take in what I just said. A hub, traffic goes out of all ports. Hence, when it communicates, basically it has a higher end for collisions because it's going across the same line or all the lines at the same time. A switch divides collision domains basically by making them into a switched environment. Now you will have to remember that when you're building a MAC address table though, if I ping, for example, it's going to go to all PCs. For example, let's go over here. Let's ping with both of these. I'm going to show you guys what a ping. Well, let's see if I can do it without let's just DHCP these. I don't think I can. Okay, never mind. It's going to get all screwy if I do that. So let's go back over here. Switch back over here. So, alright, let's, first I'm going to set up IP address right quick, guys, for all of these. We're going to do it. And that's fine. This is going to be fine. And I'm just going to do each one like this right quick. And I want to do this to show you guys an actual demonstration of this. So actually you'll see that, hey, it is what it actually does. 3, 5, that's fine. What are we on? PC4? Well, go down to PC5 next. Configure, fast Ethernet, 1.1.1. What are we going to use? Is it 4 here? Yeah, it should be 4. 255, PC6, which will be 5. 10.1.1.5 here. So these aren't actually connected. 1, 2, 3, 4, 5. Okay. So let's go ahead and configure these, and I can use the same scheme because they're not on the same switch. Oh, I'm on the gateway. Do not want that. 10.1.1.1. 255, that's fine. Is that PC? Okay, that was alright. I see which one I was on. So 10.1.1.2. 255, that's fine. It doesn't matter which PCs. I'm just trying to get this configured as quickly as I can for you guys so you can see. If you want to, you can do this the exact same way. They just got to all have different IP addresses. I don't know if I used 3 or not, but no big deal. Which one am I on? Okay, it was that one. Okay, so we're almost up. We're almost there. 10.1.1.7 on this one, I believe. So we should have one on here, I think. And we do 10.1.1.1. Okay, so in a simulation environment, let's go ahead and pull it up. We will ping 10.1.1.3. So we're going to ping that, and I want to play this across to show you guys how it works. So we're going to play it. Now notice it's going to go out of all ports at first. Now the second one's going to be a little bit different. Notice, ooh, do I not got that one? This should be a ping here. Maybe the other one wasn't. Okay, there it is. PC4 gets to ping. And there we go. Now it's going to go straight through the port the second time to it. And then it's going to send a second ping. And notice what happens. It's going to go down. Should go straight over here to PC4, which is what we're trying to ping. It won't go out of all ports. Notice how the switch now builds a MAC address table. So it knows how to switch the information. Watch, and it'll come back up. And we'll watch it through the next one also. Notice how here the path that it's going. Notice ARP. When it first starts that way, it builds ARP. I ain't worried about the STP here. But from here, we're pretty much done. So let's stop that capture. Notice STP by default is on by a switch, but notice none of these are switches, so they're going to not interpret the packet. All right, so for a hub, we've got this. So let's see. Let's go into here. IP config, so I'll make sure I'm not pinging myself. So I'm going to ping 10.1.1. Let's just do 2. Now watch what happens on the hub segment. This was the switch segment, so pay attention to the right segment. Or actually, let's reset the whole thing. I'm going to do this again. I'm going to ping 10.1.1.2 on the hub. We see over here that it's at. Now watch what happens. It goes to the hub, and then it's going to go across to all lines, except for the one that it came from, of course. Notice it's at PC12. So what's going to happen when it replies back? Watch this. Notice it goes across all lines again, except for the one that it went on. And then it pretty much ends from there. Notice STP over here is wanting to get going again. So we're going to reset the simulation. So what are we going to do? We're going to do something a little bit different. Let's do this. Let's ping. And they will do it at the same time. We're going to ping 10.1.1.2 over here. And we're going to ping 10.1.1.2 from over here also. Now watch what's going to happen here. So technically we're going to be transferring information hopefully at the same time here. And we should have some kind of collision happen. So we have that. Now let's see what happens. Already a collision. See, over here we have a collision. And look, fire, that means a collision's happening. So a collision happens. There's a back off signal sent. So the whole segment will send a back off signal, and they will randomly decide when to transmit again. Now notice it's fine right now. But now what? It's gotten back pretty much going safely. But we had a collision on the segment. So what I want you to understand here now, can the same happen on a switch? Let's see. So let's go ahead, let's reset the simulation. On here, we're going to ping 10.1.1.3. And then over here, we're going to ping the same 10.1.1.3, ping 10.1.1.3. Now let's see what happens on the switch. Oh, it only did it on one. What? Okay, hold on. Why did it not take over here? Is it 10.1.1.3 over here? Alright, there we go. So they're going to come here, the switch environment. It's going to forward out of all ports. Watch what happens here. So we got this, PC4. Notice we don't really have a collision here like we do with the hub. And information is basically controlled. And we should see one go up hopefully to here. There it goes. Then it goes back. But notice, and now it's going to be very safe on how it controls the traffic. We're also on full duplex, which y'all will learn about later on. So, alright, so what I'm looking for you guys, notice that no collision happened here as we pinged at the same time on this switch. So, why is that? So with that being done, how many collision domains will be a question that you might receive on the ICND 1 possibly. And I will point out things that I think you're going to possibly have questions on. I can't tell you exact questions as that is part of the agreement, but I would tell you, hey, this is something that you need to know. And this is one of those that you will need to know it. And you're going to see some form or fashion of this on the ICND 1, I can about promise you. So when you look at this, let's say you might have a question of how many collision domains are shown in this drawing. But we're going to divide it up. Let's say how many collision domains are on this switch over here. I'm going to give you a second. How many collision domains do you think that there is? And if you're not familiar with networking, you're probably going to answer it wrong first. But we'll get you to where you're going to get it right in this video. So you have 1, 2, 3, 4, 5 collision domains. So we have 5 collision domains. As you can see where I'm highlighting, each one is a collision domain. With that being said, let's say how many collision domains now exist on the switch? Take a second and I'll give you the answer. Alright, so we got 1 collision domain, 2, 3, 4, which is this right here, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 collision domains exist on the switch. Alright, so with that being said, let's move over to the next one, the hub over here. How many collision domains do you think exist on this hub? Take a minute. How many collision domains exist on this hub? Only 1 collision domain exists on the hub. The reason why is traffic converses as one entire line. Physically it is separate lines, but logically this is a entire line that is operating with the traffic. All of them share the same traffic through the lines, no matter what it is. Where a switch you do not, a hub you do, so it's viewed as one collision domain. Now, more collision domains would sound like it's worse than less collision domains, but indeed it is not. Separate collision domains prevents collisions. A single collision domain increases the collision chances. So, that being said, let's change this up a little bit. I'm just going to up no more available ports. So let's just pretend there's more ports in this thing. Just pretend that these PCs are connected. How many collision domains now exist on the hub? Take a minute. okay, you still only have one collision domain because it's a hub. So a collision domain still exists. So let's turn this off. I'm going to do something right quick so we can make this look right. There we go. Oh, let's turn it back on actually before I forget. I'm just going to connect these correctly. Let's make sure that that's in my real time also. Okay. So I'm going to mix this up a little bit. We're going to throw in a little bit bigger question. So I'm going to make this one a little bit different for you. Remember, switch, hub, and now they're actually connected with a crossover cable. So now, how many collision domains, you know what, we'll get actually, because that's going to get a bit confusing. Alright, so like this, with them not connected, how many collision domains are shown in this drawing? This entire drawing, how many collision domains are shown? I'll give you a minute. Alright, so let's answer it. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10, 11. 11 collision domains exist in this drawing. Remember that one collision domain is present in a hub. Everything that connects to the hub is one collision domain. Switch divides the collision domains. So there's 10 connected devices to the switch. Each one has its own collision domain. That is why a switch is the more advanced technology over a hub. A hub is considered a layer 1 device. A switch, because it deals with MAC addresses, is considered a level 2, and it works off the MAC address layer to build its table as a layer 2. So that is collision domains in a nutshell. Just remember, each port of a switch represents its own collision domain. So how many ever cables that I got running to this switch is represented as a collision domain. And over here, the hub, everything connected to the hub is considered a single or one collision domain. So you might have 2 hubs and 1 switch in a drawing. You would have to count the lines running to the switch because each one holds its collision domains, but each hub would only have 1 collision domain of itself. Now how they're connected can determine differently, possibly. Now a broadcast domain is only divided by a router. So you will learn about that later. That would actually be the next video. Broadcast domain, which we will talk about next, is divided by a router. Or a layer 3 switch can also, which is basically a router in itself somewhat, has the ability to route. So you will need to understand this. This is a very important section if you're taking your ICND 1. You will need to understand broadcast and collision domains. If you have any trouble with a collision domain and understanding how it works, please comment below and let me know, guys. If you have any questions, please PM me. If you found this video to be of any kind of benefit to you, please subscribe to the channel. And I will see you guys in the next lecture and lesson, which is B15, understanding and learning about broadcast domains. See you guys in the next video. Thank you for watching. Peace.